Hello students, today we are going to talk about very basic topic related to statistics. Okay, and first we are going to talk about data, primary as well as secondary, and next I will be talking about frequency distribution table. Here we will first talk about construction of frequency distribution table for ungrouped data and then grouped data, and in this regard we will also talk about what is ungrouped data or discrete data, and then what is continuous or grouped data. And afterwards, finally, we will talk about conversion of a discontinuous series into a continuous one, and this is very interesting. And remember, we are going to talk about through our problems. So there will be lots of solved problems here. Okay, and here basically I will be doing a construction of grouped frequency distribution table for a continuous series, and next for a discontinuous series. Okay, so let's start. What Kamraj is saying, let's go and collect term 2 marks of all the students from our class. Okay, and Gita, what does she say? She say you go and note down the heights of all the students from the cumulative record. So students, here the marks collected by Kamraj as well as the heights noted by Gita are what we call data, right? So basically data is a collection of facts such as numbers, words, measurements and observations. Now you see, for example, the staff's age in a company. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This means just by counting you get a data, you get the idea that there are effectively 10 staff members in the company, and this is the data. Right now we will talk about how to interpret this data in this chapter. So let's talk more about data. So primary data. So basically these are the data that are collected in person for the first time for a specific purpose. Here you see Kamraj has collected the data of math marks from the students in person. He has collected it in person, right? And it is, that's why called primary data. Now another example is census in a village, and more examples, collection of colors which the students like in a class. Okay. Next is secondary data. So what are they? Basically these are the data, secondary data, these are the data that are sourced from some places that has originally collected it. So what is primary data? Suppose there is some information, someone collected this information, so this is primary data. Now if we take this information from this primary data, then we will have effectively secondary data. So these are data which has been sourced from some places that has originally collected it. See, for example, over here, that's the basic idea. This kind of data has already been collected by some other persons, and you see the statistical operation may have been performed on them already. Then the question is, why are we taking this data? It might happen that there is one primary source P1. Now there can be other sources, say for example, which has been taken, and now I am going to collect all those primary sources. Say this is P3, this was P2, and then so I have got a greater pool of data. So this is secondary data, and now probably I am going to analyze all this data. Okay, so try to understand what is happening. So these are all individual collections over time or space or whatever. Suppose these are collections of different countries and I want to do an analysis of them. So I am already going to take this primary data and then I am going to do the overall analysis. So this is secondary. Okay. So here Gita also collected the data, but she took it from a record book which has already been collected, right? And this is an example of secondary data. So see, Kamraj has primary data and Gita collected secondary data. That's an example. Some more examples, the details of patta for a land that we can have from the registration office. Next, the birth date details data which can be got from the concerned office are some of the examples. Now, from this primary and secondary data, sometimes we can't get any specific or required information directly, like how many students have got more than 50 marks, how many students got marks between 30 and 40, and how many of them are with heights 125 centimeter. Next question, how many of them have heights less than 125 centimeter. Next question, how many of them have height greater than 125 centimeter. So, see, these are the type of questions that we can't get from the data. For this, what we need to do is we have to do data analysis, right? And the very first step in data analysis is tabulation of data. Okay, tabulation, basically first step of data analysis. Now, here are some of the real life statistics you can see around. Say pie charts are used in our daily life. See how much time you spend in your leisure period. So, leisure time of an average day. So, watching TV is around 2 hours, reading books 40 minutes, interacting with friends 20 minutes, listening music 20 minutes, playing chess 25 minutes, relaxing and thinking, this is the most important point, 20 minutes, other leisure activities 10 minutes. Okay. So, more or less. Next, stock market return distribution. Okay. So, here we have got both graphical distribution of data, graphical distribution of data. So, data originally has been collected, next they have been graphically shown. So, here we are seeing basically a circle graph, also known as pie graph, and here basically yet another example which is known as histogram. See the structure over there, this tells you something regarding the stock market distribution. This is particular distribution of some time period, say t. For some other time period, say t double prime, the distribution will be different. Okay. Now, these are all examples of this data analysis. Okay. So, now let us talk about frequency distribution table. So, what's frequency distribution? Well, a frequency distribution is the arrangement of the given numbers in the form of the table showing frequency, that is how many numbers how many times some number has repeated, that's frequency. The repetition number is frequency. So, frequency is basically repetition number, how many times something has repeated, with which each variable occurs, right. Now, you see there are two types of distribution table, namely frequency distribution table for ungrouped data and frequency distribution table for grouped data. Now, in this regard, let me tell you a concept of range. What's range? Basically, the difference between the largest and the smallest values of the data given. So, if this is the data, then first what you have to do is arrange it in ascending order. You can also do this in descending order, but better arrange it in ascending order. So, see, if I do that, then I will get 5, 7, next 10, next 15, next 18, next 20. Now, after doing that, just count how many numbers are there, 1, 2, 3, 4, 5, 6. Here 1, 2, 3, 4, 5, 6. So, we are okay. So, you see, what is the lowest number? 5. What is the largest number? 20. So, what is range? Range is basically 20 minus 5. See, 15. Now, this tells you the spread of the data. Basically, how much data is spread through. That's basically given by this range. Okay. Range tells you how much spread in data you can get. Okay. Okay. So, now let us do next, we will talk about next part. The first is the ungrouped data or discrete data. Now, what is an ungrouped data? An ungrouped data can assume only whole numbers and exact measurement. These are the data that cannot be range of values, and a usual way to represent this is by using bar graphs. So, let me show you. So, some of the examples are the number of teachers in a school, and the number of players in a game. Let's see an example. Okay, so form an ungrouped frequency distribution table for the weight of 25 students in standard 4 given below, and then after that you do the data analysis. So this is data, and these are the questions which will require data analysis. Okay, so this is the data, and then find the range of the weights. How many students have the highest weight in the class? What is the weight to which more number of students belong to? How many of them belong to the least weight, and all that. There can be even more questions, but for example, but to get the illustration for data analysis, only 4 have been given. Now the first step, you see over here, to form a distribution, arrange the given data first in an ascending order under weight column like this, and then put a vertical mark against each variable under tally marks like this. So the basic rule of tally is, there is, say a number is repeated, suppose, let me tell you, suppose there is some number, say x, and this number x in the data is repeated say 4 times, then I will use the tally representation as 1, 2, 3, 4. Now suppose there is another number or say variable which has been repeated 6 times, then in tally representation I will do 1, 2, 3, 4, next 5 will be a cut, and then yet another 6. So this is basically the idea for representation using tally marks. Okay, so you see, now let us look at the data. So this was our data. See, so what we are going to do is, first, the very first step would have been to write it in ascending order. Okay, that's the first step, which is not shown here, and the second step is basically this table. So after the first step you will observe something, and what is that? 15, there are so many repetitions. Look how many times 15 is repeated, 1, 2, 3. So 15 is repeated 3 times. What is the next number? Larger number, 16. Why I have started with 15? Because this is the lowest. The next number is 16. How many times it has been repeated? 1, 2, 3. That's it, 3. So you write like this over here. See? So the number 15, tally marks 3. How many times it has been repeated? So frequency, it's 3. Similarly for 16, you will find there are 4. Oh, maybe I have missed something. Let's see. 16. Let me check. Yes, there is yet another one. So 4. So you see, so this is how we do this. So there are effectively 1, 2, 3, 4, 5, 6, 7. 7 types of numbers, and effectively they are being repeated over here. Okay, and the repetitions are noted in numbers over here, and using tally marks we have given. So the question, so the first question was the range of the given data. So basically it's the lowest minus largest minus the lowest. So 27 minus 15. Next, how many of the students have the highest weight? So highest weight is 27. How many students? 2. So there are 2 of the students. Next, what's that? How many? What is the weight to which more number of students belong to? So basically frequency. Where is the frequency largest? Largest is over here, 6, and that belongs to the 25 kg group. Okay, so 6 students belongs to 25 kg, right? What was the last question? How many of them belong to the least weight? Well, what's the least weight? Least weight is 15 kg. How many of them? 3. No, not 15. You see, least weight, not the least frequency. So least weight is 15 kg, and there are 3 students belonging. Look into the question carefully. So when we tabulate the given data, it is easily to get the information. So what's the basic idea? So basic idea is that if we just look into the data, we will not be able to do data analysis and give answers to these questions. So we have to go through 2 steps. The first is to writing in the ascending order, and the next step is to draw this you see this table, and then you see we can easily, after these two steps, we can easily get the answers. So first step, next second step, and then we get the answers. So that's basically your data analysis. Okay. Now next, there are some more questions over here for you to do. Now with this information, we will move forward to the construction of frequency distribution table for group data. Now what we have been doing till now is basically we have just constructed the frequency distribution table for ungrouped data. Okay, right? So next topic is the construction of frequency distribution table for group data. Good. So first is, what is a group data, also known as continuous data? Well, a group data is any value within a certain interval. That is, the data can take values between certain range with the highest and the lowest value. Remember, here the data is more or less continuous, so it can be tabulated in what we call as frequency distribution, and they can be graphically represented using histograms. Let us see an example. The age of persons in a village, the height and weight of students in your class. Now we will consider a situation. If we collect data of marks for 50 students, it becomes very difficult to put tally for each and every marks of all the 50 students. You understand? Because if we arrange the marks in a table, it will be very large in length. The length of the table will be very large. Okay. And it is not understandable at once. So in this case, we use class intervals. That means, if this is the data, what we do, we group them according to some criteria. Okay. So this is basically data grouping. Now in this table, we will consider the groups of data in the form of class intervals to tally the frequency of the given data. So first, let us talk about class interval. Okay, class interval. Now the range of variables is grouped into a number of classes. You remember, this is the data. So now I am doing a grouping. So these are the classes, and each group is known as a class interval. And you see the difference between the upper limit and the lower limit of the class is known as class size. See, class interval is equal to upper limit minus lower limit. It's better if I show you using example. For example, you see the marks of class interval 10 to 20 can be written as, so you see class interval 10 to 20 we write as 10 to 20, and whose class size is how much? 20 minus 10 equal to 10. So class interval can be a continuous series like this, 10, 20, 30, 40, or it can be a discontinuous series like 11 to 20, 21 to 30, 31 to 40. See, 10 to 20, 20 to 30, there is no gap. So that's why it's called continuous. Whereas there is a gap between 20 and 21 in this discontinuous series. Now you see, while distributing the frequency, we follow the counting as given below. Suppose the classes 10 to 20, 20 to 30, 30 to 40, 40 to 50 and so on. Now this represents a continuous series. Here 20 is included in this class, 20 to 30, and 30 is included in 30 to 40. You understand? So basically here 20 is included in this group. Say for example, again let me say you, so let us consider this group 20 to 30. So here 20 is included, but 30 is not included. That's the basic idea. So where is 30? 30 belongs over here. Okay, so that's the basic idea. 20 is included, but 30 is not included in this case. Now in case the given series has a gap between the limits of any two adjacent classes, this gap may be filled up by extending the two limits of each class by taking half of the value of the gap, and this half of the gap is called adjustment factor. Now I will show this to you later on. Now First, let us talk about conversion of a discontinuous series into a continuous series. Look, these are some very interesting things. Normally you don't get this in your book. Now, in case the given series is discontinuous, you see we can make it continuous. How? Let's see. So, this is the series 11 to 20, 21 to 30 and so on. There is a gap of between 20 and 21. Now, what is the difference in the gap? 21 minus 20 equal to 1. Now, what we do is this, lower boundary is equal to lower limit minus half of the gap. So, what is the lower limit? Lower limit is 11. So, we subtract half with it. So, it becomes 10.5. Next, what is the upper limit? Upper boundary. So, we are calculating lower boundary and upper boundary for the new continuous group. Now, so we have got a discontinuous group, right, or discontinuous class, and now we are going to make a continuous class. Now, for the discontinuous one, we have got 11 to 20. Next, you see this is the stuff over here. They have shown 11 to 20. Now I am doing minus half and then plus half in it. Why? Because gap is 1. So I am going to make this 1 half plus half. So what I am going to do, see, lower boundary I am going to subtract half, and in the upper boundary I am going to add the half. So my upper boundary becomes 20 plus 5 and my lower boundary becomes how much? 10.5. Because I have subtracted, you see, from 11 I have subtracted minus 1, and in 20 I have added plus half. So minus half subtracted and plus half added. So this makes my new number 10.5 and 20.5. So for the continuous group, see, this is the number. 11, 20 becomes 10.5, 20.5. 21, 30 becomes 20.5, 30.5 and so on. Therefore, the class interval can be changed into a continuous one. You see the example over here. Now, let me talk about this inclusive and exclusive series. Now, in the class interval, if the upper limit and the lower limits are included in the class interval, then it is called inclusive series. What does it mean? So, for example, in 11, 20, 21, 30, 31, 40 and so on, this is an inclusive series. Why? Because in this class, both 11 and 20 are included. See, the data 11 and 20 are included in the class 11, 20. Now, what's an exclusive series? Well, if the upper limit of one class interval is the lower limit of the next class interval, then it is called exclusive series. Say, for example, 10 to 15, 15 to 20, this is an exclusive series. Why? Because you see in this, let us take this as an example. In this 15, 20, here 15 is included, but 20 is not included. Why? 20 is included in the next group, in the next class. So this is a sort of continuous series, you can say. Now, let us do some more examples. So, construction of grouped frequency distribution table or continuous series. Okay, so there is an electricity bill, probably this is electricity bill, yeah, for each of the 26 houses in a village are given below. Now you have to construct the frequency table. So see, 26 houses. Now what is the maximum billing amount over here? Look, 800. This is the maximum number. What is the minimum number? Look at the minimum number here, 120, lowest number. So what is the range? Of course, largest minus smallest. So 800 minus 120 is 680. Okay. Now, so let us take class size as 100. Then number of possible class intervals, which is basically range by class size. What's the range? 680 divided by 100 is approximately 6.8. Now, whenever something like this happens, make this a larger number. So 6.8 approximately 7. Now, had it been 6.2, you would also have taken 7. Why? Because otherwise, if we take only 6, then we will be losing this data. So even if we have 6.2, you take 7. Even if 6.8, you take 7. Even if it is 6.99, again you take 7. So If it's anything between 6.01 to 6.99, you take 7. That's it. That's the rule. Okay. So now let's do this. So class interval, you see 100 to 200 and so on, 700 to 800. Next, what's the frequency? We have done this. So after doing all this, it's important that you calculate the total frequency and see it is 26. So basically it matches with the data. You have not left out during your calculation something. Okay. Now next is this question, construction of group frequency distribution table for a discontinuous series. Now you have to convert the given discontinuous series in a continuous series. See over here, class is 0 to 5, frequency is 7, 6 to 11, 10 and so on. This is discontinuous. Why? Because this is 23 and 24. There is a gap of +1. So what do? Remember, we should fill the gap by extending the lower limits of each class by half of the value of the gap. So what's the gap over here? Gap is +1. So we will just do our usual game, -half and +half stuff, right? So the gap is 1. So subtracting and adding half of the gap. So 0 minus half becomes -half. 5 plus half becomes 5.5. So 5.5. So you see, this is our continuous series. So we have made this into a continuous series. Understand? Now suppose, let me ask you. Now suppose the question would have been 0 to 4, next 6 to 10, next 12 to 16, next 18 to 22, next 22 to 28. So this has been data and the frequency would have been the same, 7, 10, 9, again 7, 10, 9, 5, 12. So this question, suppose this has been this. How will you convert? Now look into the gap. What's the gap? Gap between 4 and 6 is +2. Remember? So what are we going to do here? We are going to do the same thing that we did previously. See, previously we did +1 was the gap, right? So we did -half and +half. Now since the gap is +2 over here, so half of 2 is 1. So we will do -1 and +1. So these gaps, okay, will become, let me show you. So they will become -1, 0 minus 1 and then 4 plus 1. So -1 to 5, next 6 minus 1 is 5 to 10 plus 1, 11, next group 11 to 17, next group 17 to 23, next group, see, 17 to 23, next group 22 minus 1, which is 23 to 29, and the data would have been the same. So see, I have just given you yet another example of conversion from discontinuous to continuous. Yes, sorry, this one would have been 24, not 22. Yes. So 24 minus 1 is 23. Okay. And then 28 plus 1 is 29.